In this video, I'm going to talk about using the binomial theorem to expand an expression out. And the expressions we use it for are when there are two terms added together, and in that whole quantity, both the terms are raised to an exponent. And I want to start here just by looking at the pattern we observe when we look at these first few ones done out. And let's not focus on the numbers here, the coefficients. Just look at the exponents and the pattern you have. So I'll start here on the bottom one. And when the exponent's 5, that first term was an x, and we have x to the 5th, the 4th, the 3rd, the 2nd, the 1st, and then there's no x at all. It's to the 0 power, so it's just the value 1. And we see the reverse with the second term here. Our y starts off with no y's, y to the 0, and then y to the 1st, 2nd, 3rd, 4th, and 5th power. And so you'll notice that same pattern in all of these, working our way up, and it would continue if we had higher exponents, 6th power, 7th power, and so on. So just getting that part down is kind of the foundation for expanding one of these out. Getting all the terms correct with the right power. And so later in this chapter, then it talks about the binomial theorem. And basically, if you raise the two terms added together to the nth power, we start with that first term to the n, then n minus 1, n minus 2, and so on until the exponent gets smaller and smaller until there's no x. The first term's not around. And the second term is the opposite. It doesn't start off right away. You don't see it, and then it's to the first power, the second power, the third power, and so on. And in the very last term, it's raised all the way to the nth. And so that is the backbone of this theorem here, how to get all the terms. All that you're missing then is the coefficient that needs to go in front. And we get those by using combinations, which I'll talk a little bit about. But that is just this symbol here means in thing combination 1, in things combination 2, and so on. And once you know how to solve that, then you can put the correct coefficient in for each term. So let's look at a problem. In this problem here, we're going to do a minus b to the 5th power. So I know with my terms that it's going to be a exponent 5, and the next one's going to a exponent 4, a to the 3rd, a squared, a to the 1st, and then there's going to be no a in the final term. And with the b's, it's going to be b to the 0, and then b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, and finally b to the 5th. Another thing you can do to make sure you have these correct is all the exponents should add up to 5 for each of the terms. Here you have a 5 and a 4 and a 1 equals 5, 3 and 2 is 5, 1 and 4 is 5, and a 5 by itself. So all the exponents add up to 5 to whatever the n is. The exponents always add up to that in each of the terms. One thing to note here is we have a minus b, and the theorem states about what to do for a plus b, and it just has a plus between every term all the way along. So if you think about it like that, right here we have a plus negative b. So we can still use the theorem. We have addition. We can rewrite that subtraction as addition. We just need to think about what a negative value is raised to the specific exponent. So a negative value to an odd exponent, the first power, is still negative. So this term will be negative. When you square a negative value, it becomes positive. When you raise it to an odd exponent again, it's negative. An even exponent, it's positive. And then any negative value to the 5th power is negative. So the only thing left to do is find out what those coefficients are that go in front of our variable terms. And so these are combinations. There's a pattern here. The first term does not have any coefficient. You'll notice the last term does not either, but the terms in between are going to be a combination with whatever the exponent was n combination 1, n combination 2, and so on, all the way up to 1 less than n. So for the example we're working here, the second term is where we start with coefficients, and it's 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4. Now, combinations are just telling us, they're helping us count things. If you have a group of size 5 and you select 3 of them, how many different ways can you form a group by selecting 3 things out of the 5? That's what this is telling us. If you had 5 things and you just select 1 at a time, how many different groups of size 1 can you select? Just imagine having 5 things in front of you, you select 1 at a time, how many unique groups are there? There's 5. Each one thing individually. So you can do some of these in your head. Any bigger numbers, they kind of get difficult. And then you want to use the formula to solve them. Your calculator, though, probably has a built-in combination key. So as long as you're comfortable and know how to use it, I recommend that. I'm going to show how to do it with an online calculator here. And I just Googled permutations calculator. There's several of them. This one works fine. So n is 5 in our example, and we want to know 5 combination 1. That's 5 like we said. For 2, it's 10. For 3, it's still 10. And 4, it goes back to 5. So there's a little bit of a pattern there. You'll always notice a pattern with your answers. For whatever combinations you're doing, as you go up, the numbers change and then they start to repeat themselves, and you'll see the pattern here. So, oops, I wrote a 4 in there by mistake. It is clearly a 5. So our coefficients are these answers to the combinations here, 5, 10, 10, and 5. And that gives us our final solution then for the expansion of what we started with, a minus b to the 5th. Now you can also use Excel if you don't want to get online. Let me zoom in here a little bit. But the formula is combin for combinations, and then the number that there are total, which is 5, and the number we're choosing. And so if you're choosing just one thing, there are 5 different ways to make the group, to make groups. If you're choosing 2 things, there are 10 different groups you can make, and so on. You'll see same results. Change it to 4 to end with, it goes back down to 5. So that's how you can use Excel. You can use the internet calculator. There is also on almost every scientific or graphing calculator a built-in combinations function in your calculator. Learn how to use that so you can quickly do this math to get what your coefficients should be.